Hello and welcome to the session on Oracle Advanced Queuing or AQ. I'm Sanjay Goyal. I'm a Vice President of Product Management in the Database Technologies Group, mainly focusing on events and microservices. As you go through this presentation, you'll see that we have started to write about application development with centralized architectures, decentralized architectures, microservices. You can catch our blogs at blogs.oracle.com/developers and look for the app dev category where you will see a lot of the blogs around AQ, microservices, and just app dev with the converged Oracle database. Let's see what this exciting 30 minutes are in front of us. We're going to talk about data-centric and message-driven app dev and what role AQ plays. We'll also deep dive into AQ, its classic queues, the transactional event queues, and we'll talk about the whole application areas of centralized applications, mainly looking at use cases. Tens of thousands of customers use AQ today, and also create interesting workflows with the messaging infrastructure. We'll end up with Oracle AQ key advantages, and maybe talk a little bit about the big picture that AQ and TEQ enable. So let's see what centralized applications are. They drive data and message integrity, and also drive simplicity, right? And if you look at what the architecture enables, is it gives you persistence of application state, right? So mainly you also get transactions for data consistency and app workflows with microservices that extend centralized applications, right? So there's the whole nature of applications being extended. So centralized applications, and we'll talk a little bit about it in the next slide, where we start to extend centralized applications with decentralized applications. And just to set a little more context, you should also see Juan Loiza's keynote on modern application development and how do you reframe that for the database. Also following that is interesting talk from Wei Hu on Kubernetes and microservices with the Oracle database, right? So all that allows us to understand what data-centric architectures are, what the role of transactions and app workflows are. And of course, the transactional aspect is also interesting with multi-tenant databases with containers that allow us to now start to use containers in Kubernetes environments and build scalable applications. Of course, developers want to code modular business workflows as easily as they can. And for coding those, there is a communication backbone. And this is where topics and PubSub with multi-consumer queues, GMS, you might even be using Kafka in some of those. So as we start looking at the messaging backbone, you'll start to see the unique aspect of Oracle AQ of delivering transactional messaging in the database. So the options to develop data-centric applications are shown here. On the left side, you see fully centralized architectures that drive data integrity, singular database. Maybe there is separation of schemas in that singular database. As you move towards the right, maybe there is service separation, but the data architecture still remains centralized. And as you move towards mini services and microservices that are decentralized, you of course get greater development agility, increased deployment flexibility, and more precise scalability. Right? If you just have one application you want to scale, in centralized architectures, you'll have to scale everything. In the decentralized ones, you could pick up, say, the supply or the shipping microservice to be scaling depending on demand. So just to summarize this one, centralization on the left side provides specialization, efficiency, consistency, and some simplicity. On the right side, decentralization provides independence and outcome orientation. Now, some of this may seem to be complex. However, design patterns, microservices patterns that you would have seen in Wei Hu's talk show us how these can be simplified as well. So again, there's no right or wrong here. It's a matter of your choice and the combination of centralized and decentralized architectures that seem right for your organization. The simplicity that comes from database convergence is shown here. So on the left side, you see producers of information, of data, of events, of code events. It's all sorts of events come from the producers that, again, with things like transactional event queues or Oracle AQ, translate through the database and into consumers of those. Like, so a messaging framework like AQ can provide the transport mechanism for events and data that consumers of mobile applications, search portals, and others can consume easily. And the data integrity across all data and events is provided by AQ. Microservices support, again, several patterns of microservices are shown to be supported here. And then open interfaces, easy app building blocks. And again, just because you use the database, there's less to learn, manage backup, because that's all very familiar to Oracle database customers. And using the autonomous database, which is where AQ is also available, self-managing infrastructure is available there. So let's talk a little bit about AQ, how long it has been there in the Oracle database. Was introduced in 8.0. It's a single queue with a message stream. Oracle AQ sharded queues were introduced in database 12.1. And these have been around for a while as well. These are partition queues with multiple shards per queue, gives you automatic partitioning, multiple queue, message streams. Again, an extension of AQ, and gives you better performance, right? So it's got in-memory implementation. It's also got partitioning, right? So again, AQ and AQ sharded queues have been around in the database. In database 21C, we renamed Oracle AQ sharded queues to transactional event queues. So this TEQ that you see is a renamed sharded queues, and we'll talk a little bit more about what these enable or what kind of use cases they enable. Let's talk a little bit about exactly once messaging, right? The importance of transactions and combined data and message integrity. Like on the left side, you see a transaction T1 that writes into a table and sends an event A. Right? So this is an atomic operation, and this is where DML and an event in a database transaction is unique to Oracle AQ because it's implemented in the database. On the right side, as a consumer, you also receiving an event as part of a transaction T2, you process the event and you send an event B. So this receiving, processing, and sending is an atomic operation. So this is, again, a transactional workflow. And if you don't have the support, code becomes complex. You need to handle, duplicate events. You need to do dedupe. There's a lot of complexity involved in writing code. And this whole guaranteed delivery exactly once for an event and creating chained events, again, reliably, consistently is what Oracle AQ brings to the table here. Here's a more broader picture of what Oracle AQ does. In the center, you see the Oracle database with advanced queuing built into it. It's basically a queue table, which acts like a broker for a message stream. Right? These are persistent queues, disk-based, and support multiple languages. There's also buffered queues that are supported, but not as oftenly used because people like persisting their messaging system as well. Producers can produce or publish, and they can publish in PL/SQL, JMS, C, Python, Node.js, and .NET. We also have REST interfaces coming. On the right, you see consumers, consume, and subscribe. So again, you can do produce consume as you do in a message where you have a directed consumer, or you could do pub sub where you publish and then subscribers subscribe to that topic. AQ also supports queue propagation. So again, a message stream can be propagated to a remote database, and that remote database then can have consumers there, right? So you can imagine having a global database of sorts where the messaging system can produce at one point and consume from somewhere else. And this is a very widely used use case. There's also a messaging gateway that can take messages from IBM queue and bring them to Oracle AQ or vice versa. Right, so again, kind of gives you the flow of what AQ as a messaging system is all about. Here's a brief history. Again, we talked about AQ being around since Oracle 8.0, but recently, over the last couple of years, we've done a lot of work in the sharded queue area. We have made them more robust, more performant, and renamed them to transactional event queues with Kafka compatibility. I have another talk where you could look at Oracle TEQ and Kafka compatibility for creating an event mesh, right? So this whole event mesh architecture is very important to send events and messages to microservices wherein, when they need them, and by routing them, by making them secure, by making them highly performant, right? So that's the area of Oracle Transactional Event Queues. And Oracle AQ classifies a single database workloads, and they continue to evolve. They continue to be the workhorse for creating workflows, and we'll see some examples in a couple of slides. So here are some of the common use cases. Again, as I said, it's very widely used, tens of thousands of customers across Oracle applications, across banks, retail, healthcare. Right, so and some of these use cases are around consolidating events into a central repository from remote sites. It's about sending messages to run marketing campaigns. Banks using several leading banks use messaging for OTP security, one-time password, event consolidation from IoT devices and sensors come through Oracle AQ. And simple application microservices, workflows, and sagas. Sagas are basically transactions across microservices that are supported with AQ messaging. Job scheduling and control planes, cloud control plane or any other control plane you will be writing. And then, of course, identity management, control flows. Anywhere you kind of see messaging, you see the area of AQ. Again, I use messaging and events interchangeably, but again, both have a place in the nomenclature. So here's how multiple app workflows have been architected. So on the left side, I show a few of the traditional workflow alternatives. In the age of middleware, there used to be a message event bus where 4 services, that is an example here of an order service, of an inventory service, shipping, supplier, these services, they interact with a message bus. And you can see that in a WebLogic JMS message bus as a middleware. Another way to do is to do REST APIs, and each service exposes REST API. These are typically synchronous REST API calls, and they may or may not support transactional interfaces. Workflow engines are also being used, and they seem to be supporting fairly complex workflows. Now, if you're coding simple workflows that require messaging, on the right, we show a pub/sub of topics with Oracle AQ, where these services, each of them have a topic on which they publish, and then the other services subscribe from those topics. And we'll see that in the next slide. This is included, again, the advantages of Oracle AQ. It's included for free in the Oracle database, and it's included across deployments. Has multiple language support, so want to write it in Java, want to use PL SQL, want to use Python, want to use Node.js, it's got all the support, and then has transactional messaging at the core, right? So again, makes writing producer and consumer code much simpler than other traditional messaging systems that don't have transactional messaging. So here's a blog that's referred on the left, the bottom. A PL SQL microservice, simple, concise, and fast. This is again at the developers blog site, blogs.oracle.com/developers. You can basically see this example where there are 2 services, order and inventory. Order has an order topic, it publishes to inventory, publishes to an inventory topic, and the other microservices subscribe to that topic. Right? So you see the pub sub here. And the order service sends a message, and the inventory service gets it, checks. So that processing happens, checks, and then sends the status back saying success or failure, and publishes to inventory topic for which the order topic then subscribes. Right. So you basically see a simple workflow, and the code example is on the right here. For AQ users who have been using AQ, we always get some questions around performance. Again, AQ is performant for many workloads. It works well. So if you're looking at, say, about 200 million messages a day, it does very well on a single database. You can, of course, get higher throughput with multiple databases as well, right? So again, if you're happy with this, about 2,500 messages a second, AQ is a great choice in the Oracle database. However, for use cases with even higher messaging rates, you should consider moving to TEQ, Transactional Event Queues. They have same APIs, except a couple create, alter, drop, where you can, of course, require some code change. But usually we recommend this to be when your app changes. So if your app is getting upgraded, you can then move from AQ to TEQ. And in the new application version, as you go through its upgrade cycle, use TEQ, test it out. In memory persistent queues, high performance, you would probably get anywhere from 5x to 10x performance based on a single node itself. And then with rack scaling, you can get even further performance improvements. So again, gives you the same message ordering. Here, the message ordering is per producer, per event stream. So, you have to be cognizant of the fact that you have now multiple event streams. And as you're producing, the order is maintained within that event stream per producer, right? So slightly different than using AQ, where you only had a single event stream. PubSub and point-to-point, exactly once messaging, all the good points of AQ, multi-language access. So you see that it's got a lot of the areas that AQ provides, but then now it's got to go. It also provides Java client and Java or Kafka JMS connector. So you Kafka interoperability, or even in some cases you have Kafka produce consume code in Java. You can replace the Kafka broker and use TEQ instead for some cases, and simple enterprise grade security. So TEQ, again, consider moving to it if you have high throughput requirements. As you see, the layout here is pretty much same as what you saw in the AQ one. Produce, consume, publish, subscribe. The broker, now you start seeing as queue tables, multiple event streams, right? So I talked about event streams, ordering of messages being per event stream, per producer, right? So your queues are now partitioned. You get a Kafka JMS connector, so you can interoperate with Kafka. You can also get a Kafka Java client. You can publish and subscribe with Kafka Java code, and then queue propagation happens at an event stream level, right? So again, very similar to AQ, just that you get the nomenclature of queue tables and event streams, and very similar to what you are perhaps familiar with Kafka with topics and partitions, right? So topics and partitions in Kafka map to queue tables and event streams in TEQ. Some of the key features, I think I've talked a little bit about AQ key features and its performance, right? So again, exactly once, total ordering of messages. Again, the contrast of total order versus per partition order, PubSub of topics, right? And then the built-in support for microservices. Let's talk a little bit about transactional outbox, which is this ability to write into a table and send a message within a transaction, right? And idempotent consumer. The consumer then is already guaranteed that the messages will be delivered exactly once. It doesn't have to go do redo and eliminate duplicate messages. Language support continues to be expanded with REST APIs being built, and again, it supports interoperability. So AQ supports interoperability with the IBM MQ, and as you upgrade to TEQ, you also see interoperability with Kafka there. And we're also putting a lot of effort in queue stats and continuous real-time monitoring with Prometheus and Grafana. So if you've been using AQ and you've been wanting to monitor these things, please connect with us and look at the monitoring aspects with Prometheus and Grafana that give you insights into how the queues are functioning. Things like queue depth, things like producer throughput, consumer throughput, and any level of $V statistics that we have been used to looking at it. So as we summarize this presentation, again, AQ and TEQ are part of the same set of messaging systems in the Oracle database and will support application development. So as you modernize your applications, be it centralized or decentralized, simplified workflows with microservices running on all cloud platforms. It's included as part of the Oracle database, integrates with Kubernetes, Docker containers, service mesh, has high throughput messaging. It can go as high as 1 trillion messages a day with racks and sets of racks that you can set up. And again, combination of the best of messaging and PubSub with exactly one's delivery guarantees. And best total cost of ownership from not only the messaging standpoint, but simplified code, standard programming interfaces, skill set development, and then built-in recovery from failure. Just to summarize, my final slide here is, again, AQ, classic queues, and TEQs are part of the Oracle AQ brand. They are free in the database. So if you have the Oracle database, they're in containers, in Docker, you can deploy this in Kubernetes, cloud services, autonomous database. Number two, Oracle AQ helps develop workflows for enterprise applications, again, with the events and messages as being the underpinnings of workflows. And lastly, transactional events with converged database, simplify microservices. So we have spent a lot of effort in live labs, right? There's a converged database live lab that talks about using AQ for microservices. We built a mobile food delivery app called GrabDish. You can look at the hands-on lab that is part of these sessions, where you can see a converged database, microservices, and AQ and transactional event queues. So AQ classic for simplified app workflows, and then TEQ for using as an event mesh in microservices. Some of the sessions you should check out. Again, the keynote from Juan Loiza, Rethinking Database Architecture to Embrace Modern App Dev. Another session on Kubernetes and microservices with Oracle Database by Wei Hu. My other on-demand session, transactional events using Oracle TEQ and Apache Kafka. We'll talk about more of the compatibility with Apache Kafka. And then the hands-on lab I mentioned, simplifying microservices with converged Oracle database. Here are two product resources, the Oracle AQ TEQ Users Guide. It's a bit small bit.ly link. So hopefully you can remember this, you can take a note of this. And then a lot of the app dev stuff, again, a bit.ly link, data-centric -app dev. So we're going to go put a lot more of how application development is simplified with the Oracle Converged database on the Oracle Cloud. Talking about the Oracle Cloud, you can get a Oracle Cloud free tier account. It's always free, plus the 30-day free trial at oracle.com/databaseworld free tier. So thank you. I hope you enjoyed this conversation, and we'll look forward to hearing back from you. Thank you.